I'm Richard Dawkins, former Professor of the Public Understanding of Science at Oxford University, author of The Selfish Gene, The Blind Watchmaker, The God Delusion, and The Greatest Show on Earth, among others. The word theory can be used to mean something speculative and tentative. In everyday speech, it probably usually is used in that sense. Scientists very often use it in a much more positive sense. I think the easiest way is to use the ordinary language word fact. In the ordinary language sense of the word fact, evolution is a fact. Evidence that makes it a fact is partly fossil evidence, partly comparative evidence, looking at modern species and comparing their bones, their organs, their structures generally, and especially their molecules, their genes, at a molecular level. This is extremely persuasive and powerful evidence. You compare the genes of animals and plants, you find that the pattern of resemblance is a tree, a branching tree, and that branching tree could only be a family tree. Other very persuasive evidence is the geographical distribution of animals and plants on islands and continents. They are exactly where we should expect them to be if evolution were a fact. Natural selection chooses among self-replicating entities. Those self-replicating entities have some kind of power over their probability of being copied, of being replicated, of being passed on. In practice, that almost always means choosing between alternative DNA genes. So it's about the natural selection, the disproportionate, it's about the unequal survival of genes through generations. That is natural selection. We see it in the form of changes in phenotypes, that's to say, changes in bodies, because it's through the changes in the bodies that the genes induce that they ensure their survival or fail to survive. The ones that are good at surviving are the ones that are good at building bodies that are good at surviving and reproducing. We're gene machines in the sense that a body is constructed by genes that have been successful in surviving in the past. They're good at surviving because they're good at constructing machines in which they survive. So a body is a machine for the propagation of the genes that built it. One important active area is the origin of sex and why we have sex at all. It's controversial and interesting and unsolved. Another one, I think, would be the evolution of consciousness, especially human consciousness. Another one would be the embryological routes by which genes influence body. The mystery there is that on the view of the selfish gene, every animal is trying to maximize the number of genes that it passes on. And so mixing half your genes with those of a sexual partner seems like an odd thing to do. And on the face of it, it's throwing away half your genes with every child you have. So it needs an explanation, and various explanations have been suggested. I suppose the most fashionable one now is the one that's associated with the name of W.D. Hamilton, my former Oxford colleague. He took the view that parasites are the most important selection pressure bearing on creatures, and that parasites, because they are, especially bacteria, evolving so incredibly rapidly, the genes that any one individual needs in order to survive in the present generation of parasites may not be the genes that are needed in future generations. So there needs to be an extremely rapid turnover, extremely rapid changing of gene pools, and sex may be, well, sex certainly will do that, and the only question is whether the pressure from parasites is sufficiently great to compensate the so-called twofold cost of sex, the fact that sexual reproduction does throw away half the genes in each generation. I think first the realization that there are lots of different religions and they can't all be right. and the Christian one in which I was brought up was clearly only one of many. But that didn't finally make me into an atheist. What finally made me into an atheist was the realization that there was no scientific reason to believe in any sort of supernatural creator. And that came with the understanding of Darwinian evolution. In the sense of faith as meaning belief in something for which there is no evidence, there are various senses of faith in which scientists do participate. Those branches of science which I don't understand, for example, physics, it could be said, I suppose, that I have faith that physicists understand it better than I do. And so when I say something that physicists tell me, such as that there was nothing before the Big Bang, you're not allowed to talk about the word before in the context of the Big Bang, I sort of have faith that physicists understand enough to be allowed to say that, even though I don't understand why they're allowed to say that. But it's not faith, it's not blind faith, it's not faith in the absence of evidence. It's faith that's based upon confidence in the scientific method, in the scientific peer review process, the fact that I know that there are other physicists who can test, verify, criticize the views of any one physicist. So it's not the same as religious faith, which is based upon Well, it's certainly true that so many people do have religious faith, not just individual people, not all individual people do, but all cultures. I think I'm right in saying that all peoples, in the plural, have had faith, religious faith of some kind. They believe in some kind of supernatural gods or goddesses or leprechauns or whatever it might be. Why do they have it? Well, I think it's very tempting when you don't really understand what's going on, when you're ignorant of the world, when you find yourself surrounded by a wonderful world, a puzzling world, a mysterious world, a frightening world. It must be quite tempting to put your faith into a supernatural being of some kind. Science is not in the business of shedding light on moral debates, but I think it can do sometimes. The whole subject of moral philosophy, of examining moral questions in a logical way to expose inconsistencies, for example. When you're looking at moral questions, so-called moral questions like abortion or euthanasia, you can show that people who take a very strong absolutist line may be being inconsistent with themselves because they are taking a strong line on one thing while at the same time inconsistently not taking a similarly strong line on another. So that would be a scientific way of thinking. It's not science per se, it's moral philosophy, but it's a kind of scientific way of thinking. But also I think scientific facts can illuminate moral debate. In the case of abortion, again, for example, a scientist might contribute to the debate information about at what point during the development of an embryo the nervous system comes into being. And presumably before the nervous system comes into existence, there is no ability to feel pain or to suffer. And so maybe something important happens at the moment when the nervous system comes into being. On the other hand, you might say, well, even when a human embryo develops a nervous system and develops the capacity to perhaps suffer, it's still a much smaller nervous system than the nervous system of an adult cow. And so what about balancing the suffering of a human embryo against the suffering of an adult cow when it's being slaughtered for meat? An absolutist moralist would say, well, humans are just plain special, and cows are not human, so they don't deserve the same moral consideration. But a scientist might come along and say, well, what do you mean by that? I mean, we are, after all evolved, we're all cousins. At what point in the evolution of, since we know evolution is a fact, at what point in the evolution of humans would you suddenly draw the line and say, right, from now on they're all human, and before that they're not? In the evolutionary progression from the common ancestor with chimpanzees, lived about 6 or 7 million years ago, to modern humans, going through creatures which might have looked a bit like Lucy, might have looked a bit like the newly discovered fossil Ardi. Would you have given special human, moral, ethical consideration to Lucy, or would you count Lucy as though she was a chimpanzee? Does this perhaps suggest to you that we shouldn't be in the business of drawing lines between species in this kind of way? Maybe these lines should be regarded as more fuzzy and less clear-cut. Are absolutist moralities that do draw hard and fast lines between humans and all other species, even taking a human fetus and calling that human, and whereas an adult chimpanzee is not, and doesn't deserve the same moral consideration, is that consistent with science? These are ways in which science can at least inform. You can, I suppose, make a utilitarian justification for obnoxious practices. You could make a utilitarian justification for torture. Moral philosophers sometimes pose the hypothetical case where the world is about to be blown up. Only one person knows the secret password to stop the doomsday bomb going off. This one person is a suicide bomber who refuses to give up the password. Are you right to torture him? And most people, I think, say you are. I mean, it's a horrible thing to torture somebody, but under those extreme conditions, to save the world, you would torture somebody. So that would be a utilitarian justification for an otherwise obnoxious practice. In the moral sphere, I think they would be based upon criteria such as suffering, instead of absolutist criteria like all killing of humans is wrong, for example, including killing of early human embryos. We would instead say, well, who's suffering? At what point in the balance does the suffering switch over to the other side when there's a choice? If we got rid of absolutist moral criteria, we might stop saying human life is absolutely sacred and you can't put a monetary value on it. You actually do put a monetary value on it all the time, because, you know, whenever you make a decision like, shall we have another kidney machine, or shall we, to what safety standards should we build airliners, one could always make airliners a little bit safer, but it would cost a lot more money. And so we do already take decisions about that. Military aircraft are built to a less risk-averse standard than civilian aircraft. We already do make judgments of this kind. So that would be the moral, that kind of thing would change in the moral sphere. In the scientific sphere, we'd be able to get on with our science as science and not have to worry about whether we are giving offence to people who get their beliefs from holy books rather than from evidence, which we at present have to worry about. In the field of education, we could go in for science education free to actually teach children the best science we know, teach children to use the scientific method of thinking, and once again, not have to pay lip service to or respect the dopey beliefs of their parents who try to interfere with their scientific education. Suppose in my own field of biology it would be molecular genetics. It has enormous potential. It's advancing at an extremely rapid rate, coupled with computer science, which is also advancing at an extremely rapid rate, and the two are genuinely coupled. That's no accident. Moore's law in the world of computer science states that computer power measured in various ways increases exponentially, and its doubling time is something like 18 months. There's another law which I've coined Hodgkin's law, which says that sequencing genomes, the power to read genomes, increases exponentially, and the doubling time is not quite as fast as that. It's more like 27 months. But Hodgkin's law and Moore's law are related because genetic sequencing the technology is very dependent upon computers, and so part of what has fed into the increase in the rate of the increase in the power to sequence genomes has been the increase in computer power, which is Moore's law. So the two together are rendering our world ever stranger, ever faster, and the internet, as we now know it, would have totally astounded me if, when I first started using computers in the 1960s, I dimly thought that something like the sort of internet mass communication might come about, but I never thought it would be anything like as powerful as it is. I would have been just blown over backwards if somebody had suddenly plonked me in front of a modern, pushed me forward in time to 2009 and shown me a modern computer and a modern internet connection. That the same thing is happening and is going to happen to biology with respect to genome sequencing. And it's going to become possible to sequence the genome of an individual, of any species, for very little money, very fast. And that's going to open up enormous vistas for biological research and for medicine, because it means that, for example, doctors, instead of prescribing a sort of generic treatment for the disease you've got for an average person, will prescribe the particular treatment that you as an individual need because of the particular fingerprint of genes that you've got. And that's going to be a radical change in medicine. But in biological research, it means that we can just sequence the genome of any species we like very quickly. Biologists of the future may be able to catch an animal or plant in the wild, stick a probe into it, and immediately read out off a sort of iPhone dial its genome. This would be an astonishing leap in research power. It's coming closer all the time. It's already possible to sequence a genome for a few, I forget what it is, but I mean it's a manageable number of dollars. It's still a lot, but by 2050 it would be possible to sequence the genome of an individual for probably tens of dollars, and that would be quite an extraordinary state of affairs. Well, that's very interesting. You asked me who my heroes were, and I said Darwin. Darwin, I think, misdiagnosed his own character traits, rather. He said that I've become nothing more than a machine for grinding theories out of facts. I don't think Darwin was that at all. Darwin was a great hypothesis former. Darwin thought of ideas, he dreamed up ideas, and which is the way scientists ordinarily do work. So I think you need to be imaginative. You need to have the imagination to put together ideas which other people haven't had. You do need to be able to work hard. Sir Hans Krebs, who discovered the Krebs cycle, once in my presence was asked, how do you get a Nobel Prize, which he had? And he said, it's easy. You come into the lab at 9 o'clock in the morning and you leave at 6 o'clock in the evening every day for 35 years, or words to that effect. I don't think that's how you do it either. No doubt that's part of it. But you need a combination of that and genuine inspiration, which is akin to poetry, it's akin to great art. It's the inventive, creative leap which great scientists have.